Thank you. So good afternoon. My talk is on the development of a novel first-in-class CRISPR-based diagnostic platform for point-of-care diagnosis of fungal keratitis. Despite afflicting more than 1 billion people and causing more than 1.5 million deaths annually, fungal infections unfortunately remain a pernicious neglect. This is best exemplified by the misdiagnosis rate of fungal infections across various organ systems. Hence, there's a huge unmet need to improve fungal diagnostics. So for any new diagnostic modality, it's important to understand the unmet need for that particular condition. For fungal keratitis, there's a huge unmet need to diagnose fungal keratitis at the primary healthcare level. So our purpose was to develop a rapid, non-invasive, cost-effective point-of-care test to diagnose fungal keratitis using CRISPR, which we have termed RID-MYC, which stands for Rapid Identification of Mycosis using CRISPR. So before this, a brief introduction to CRISPR. In one line, they are the antibody equivalents of prokaryotes. So when we as eukaryotes come across a virus, we recognize their proteins and produce specific antibodies against them. While given the primitive state of the prokaryote immune system, they rather recognize foreign sequences and engineer Cas enzymes to identify and cleave these nucleotide sequences. So this is the workflow of the assay. It includes 4 processes. First is the DNA extraction, followed by the isothermal amplification, which amplifies the target fungal DNA if present, followed by the CRISPR reaction, which in the presence of the amplified fungal DNA cleaves a fluorescent reporter, which is visualized as fluorescence. So because our aim was to develop this both as a point of care test and as an alternative to PCR, we included 2 readouts. First is the qualitative binary interpretation, which makes it ideal for point of care testing, and the quantitative readout, which makes it easy to predict fungal load in tertiary facilities. So the first step was to test the specificity of the assay. As seen here, a positive test was seen with all tested fungal DNA, but not with bacterial or human DNA. Then we tested the analytical sensitivity of the assay. This was around 13 to 16 genome copies for these common fungus, which was better than pan-fungal PCR. So then we tested the clinical validity of this assay. So the sensitivity and specificity of RID-MYC was superior to PCR. But however, to assess its applicability as a point of care test, we first dissected the process into 4 distinct steps: DNA extraction, isothermal amplification, CRISPR reaction, and visual detection, and assessed it against WHO's assured criteria for an ideal point of care test. When we did this, we realized the DNA extraction step was accounting for 56% of the cost, 45% of the time, required the most expertise, and required complicated equipment, and was the only step which was dependent on electricity. So we wanted to bypass this and see if we could develop a assay without compromising on the sensitivity and the specificity. So we have precedents for this. We know that direct PCR without nucleic acid extraction works as well as traditional PCR, but greatly improving its clinical utility. So first, we looked at the concordance between these 2 methods. So the extraction-based methods requires lysis and followed by DNA extraction, and the whole process takes 25 minutes. While here in the extraction-free method, a shimmer strip is placed on the ulcer and directly subjected to the RID-MYC assay. So the concordance between these 2 was 100%. The next step we saw was what is the time to achieve a positive diagnosis. Here we measured the fluorescence using a spectrophotometer, and we saw the time taken to cross the threshold. So there is no significant difference: 23 minutes with an extraction based method, while 25 minutes with an extraction free method. So this video shows the workflow of the assay. Shimmer strip is placed on the cornea, and then followed by the RPA reaction, which happens at 37 degrees Celsius for 30 minutes. It's important to note that the pipetting is the only expertise which is required, and heat block is the only equipment which is needed, which can function without electricity. This is followed by the CRISPR reaction, which happens at 10 minutes. Followed by the visualization. So after this phase, we went on to again clinically validate this assay in 146 patients with smear positive microbial keratitis. The operators of the RID-MYC assay were blinded to the results of other conventional mycological methods. So being a nucleic acid detection modality, we tested it against the PCR. The sensitivity of RID-MYC was 94.5% better than PCR, and the specificity was 84.62%, again better than PCR. So the concordance of RID-MYC with culture was 76%, which was similar to the concordance rate between KOH and culture, and the concordance between KOH and RID-MYC was 94%. So this shows the mycological spectrum of the species detected by the RID-MYC assay in clinical specimens. It was able to detect Aspergillus, Fusarium, Curvularia, Candida, Xerohilum, Bipolaris, Cylindrocarpon, and even Dementicious fungi. We did not come across a species which was not detected with this assay. So now again coming back to the assured criteria. So now we compared how it aligns with WHO's criteria for a point of care test. So RID-MYC is the only assay which can be performed without electricity. It takes less than 60 minutes. It's only 45 minutes the mean time, and the sensitivity and specificity is comparable to PCR. At this point, it costs 350 rupees per sample, but there's no batch effect like a PCR. Each sample is going to cost the same, which will come down with mass production. So to conclude, this is the first CRISPR-based system reported for the broad range diagnosis of fungal infections in any organ system. It is the first CRISPR-based system for the diagnosis of any ophthalmic condition. DNA extraction-free RID-MYC reduces the time and cost by half and is not dependent on complicated equipment or electricity. It is a point-of-care test that can be applied at the primary healthcare level. We are now in the process of multiplexing it for species differentiation and also for the identification of antimicrobial resistance genes. Thank you.
I just wanted to find out that you do that normal PCR, that
Yes, sir.
you get that broad 16S RNA region, but that detects all types of fungus.
Yes, sir.
But do you miss by this procedure some fungus
No,
species?
so we did 3 times, sir. In silico testing, we tested 20 pathogenic fungus, which detected. On the lab, we tested 9, it detected. And in the clinical specimens, in the 146, we have not come across any species which was not detected by the RID-MYC assay.
Wonderful.
Thank you.
Thank you.
Thank you.